Assalamualaikum, my name is Khairul Nazmi bin Kamar Bahrain, student ID 2025890312.
My name is Muhammad Ilham Haikal bin Nur Hassan and my matrix number is 2025692224.
My name is Abdullah Zamir Razali. My matrix number is 2025425846.
My name is Muhammad Zidan bin Muhammad Fuzi and my matric number is 2025801578.
Today we have 3 questions to solve, and the question number 1 is presented by me, Khairul Nazmi bin Kamar Bahrain, and that is explain the relationship between differentiation and the tangent line to a curve. So to start it, think about the straight line on a graph. Finding its slope is easy, it's just constant and never change. But what happens when a line bends into a curve? A curve doesn't have just one slope, its steepness changes at every single point. So how do mathematicians figure out how far something is changing at one exact split second on a curve? They use two more of the most famous concepts in calculus, called the tangent line and differentiation. So to visualize this, imagine a roller coaster twisting through a loop. If you freeze the frame at any random second, where is the coaster actually pointing? If you do a straight arrow shooting out from the front wheel, that arrow will be perfectly match the coaster direction for that one frozen moment. In geometry, the straight arrow is called tangent line. It is a straight line that just grazes a curve at a single point, mimicking the curve direction at that exact spot. But here's the puzzle. To find the slope of a straight line using normal algebra, you need 2 points. But a tangent line only touches the curve at one single point. Normal algebra breaks down. You are stuck trying to divide by 0. This is where differentiation comes to the rescue. Differentiation is the algebraic engine of calculus. It's the mathematical process you run on a curve equation to smash the distance between 2 points down to practically 0. By doing this, differentiation calculates the exact numerical slope of that tangent line. So, what is the ultimate relationship between them? Differentiation is the tool and the tangent line slope is the result. When you differentiate a function, you get a slope generator called a derivative. Plug in any point on your curve and it tells you exactly how steep your tangent line is.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham Haikal and I will explain about question 2. So, in this question, we need to differentiate each variable in this question. So, first one is ln x, y. It will be ln x minus ln y. So, this one, differentiate this one will be 1 over x minus 1 over y dy dx. So, second one is cos x power of 2 y. Differentiate this, it will be minus c x power of 2 y. Third one is 3x power of 4, it will be 12x power of 3. And the fourth one is minus e x power of x minus y. This one will be minus e power x minus y multiplied by 1 minus dy dx. This one is from differentiate power of x minus y. So expand of this, it will be minus e x minus y plus e x minus y dy dx. So susun balik all of this, so it will be 1 over x is minus e equal to 12x over 3 and minus e x plus e x by dy dx. Okay, the next part I will leave to Azam.
So I'm going to continue this question. So this is where left to me to answer the question. So we're going to find the dy over dx. I'm going to find the dy over dx by step. I'm going to show it step by step. So first step is we are going to grouping dy over dx terms to left side. So right now we have 1 on the right. So we're going to take it to the left and this sign will be changed to negative. This one. And on the left side have one equation that does have any dy over dx. So I'm going to take it to the right, and we're going to have this equation. So this one is optional, but I'm going to do it so that we have a cleaner equation. So next step is by factor out dy over dx. We're going to factor out dy over dx, and we're going to have this equation. So we have this, right now we have this in multiplication, but I'm going to take it from the left side to the right side, and it will be divided. So we're going to have this equation, dy over dx equals to the equation. So right now we don't answer it because we have 1 over x. When we have 1 over x, this and this, we're going to eliminate it by multiplicate with xy over xy. So we're going to multiply with xy over xy. So we will have this equation, and this will be our final answer. That's it.
Hello, my name is Muhammad Zidan, and I will be presenting the step-by-step solution for question number 3. So in this problem, we have to use linear approximation to estimate the value of cube root 4 plus 1.99 square plus 2 over 1.99 square. So for the first step, we have to define x and x naught. We will let x equal our target decimal, which is 1.99, and for x naught, we have to choose a whole number that is the closest to 1.99, which is 2.00. Now moving on to step 2, we set up our function fx by replacing 1.99 with the variable x. This gives us cube root of 4 plus x squared plus 2 over x squared. To prepare this function for differentiation, we can rewrite the function to fx equals, in brackets, 4 plus x squared with the power of 1 over 3 plus 2x with the power of negative 2. For step 3, we need to determine the general derivative function f prime x. To do this, we have to use chain rule and power rule, and the formulas are as written on the screen. We will handle this term by term. For the first term, which is 4 plus x squared with the power of 1 over 3, we apply the chain rule. We bring the power of 1 over 3 to the front, subtract 1 from the exponent to get negative 2 over 3, and then multiply by the inner derivative of 4 plus x squared, which is 2x. This simplifies to 2x over 3 times 4 plus x squared to the power of positive 2 over 3. For the second term, we apply the standard power rule. Bringing the power down and subtracting 1 gives us negative 4x to the power of negative 3. Or to simplify, negative 4 over x with the power of 3. Combining these two parts, our final derivative function is f prime x equals 2x over 3 times 4 plus x squared with the power of 2 over 3 minus 4 over x with the power of 3. For the fourth step, we have to substitute the values into the formula. First, we find fx naught by using f2, substituting 2 into our original function. This simplifies to the cube root of 8, which is 2, plus 2 over 4, which is 0.5, which finally equals 2.5. Next, we can find f prime x naught by substituting 2 into f prime. We will get 4 over 3 times 8 to the power of 2 over 3 minus 4 over 8. Finally, it will be 4 over 3 times 4 minus 4 over 8, which then the final answer will be negative 1 over 6. We now have all the components required to complete our linear approximation. Fx naught, which is f2, equals to 2.5, plus f prime x naught, which is f prime 2, which is negative 1 over 6, and finally x minus x naught, which is 1.99 minus 2. Altogether, it will be 2.5 minus 1 over 6 times negative 0.01. And then it continues with 2.5 plus 0.001667, and the final answer will be 2.501667.
In conclusion, mastering differentiation, implicit technique, and linear approximation allows us to decode the behavior of complex curves and estimate real-world values with precision. That concludes our presentation for MAT183. Thank you for watching. Okay, itu Nazmi keluar.